Weierstrass Theorem statement: an analytical function comes arbitrarily close to any complex value in every neighborhood of an essential singularity. Now proof: consider the function f of z minus c. If point A is a limiting point of f of z minus c, there is nothing to prove. Suppose A is not a limiting point of the function fz minus c. Fz minus c does not equal to 0 for modulus of z minus a is less than delta. Suppose that Lorentz expansion for gz is equal to sigma n varying from 0 to infinity a n bracket starts z minus a bracket close raised to power n plus sigma n varying from 1 to infinity b n bracket starts z minus a bracket close raised to power minus n. Modulus of z is greater than 1 upon epsilon because f of z minus c is less than 1 upon epsilon. Suppose modulus of gz is less than 1 upon epsilon, bn is equal to 1 upon 2 pi integral over c, bn is equal to 1 upon 2 pi iota integral over c bracket starts z minus a bracket close raised to n minus 1 gz dz, where c such that modulus of z minus a is equal to rho, where rho is equal less than delta, on c such that z minus a modulus and modulus of gz is less than 1 upon rho, so modulus of bn is equal to modulus of starts 1 upon 2 pi iota integral over c bracket starts z minus a bracket close raised to n minus 1 gz dz modulus close equals to modulus of bn is less than equal to 1 upon 2 pi 1 upon epsilon rho raised to power to n minus 1 2 pi rho equals to 1 upon epsilon rho n. Thus modulus of bn is less than rho n upon epsilon tends to 0 because rho tends to 0. Thus we must have bn is equal to 0 for all values of n is greater than 1. So gz is equal to sigma n varying from 0 to infinity a n z minus a raised to power n. So gz has a removable singularity, that is gz is a analytical at z is equal to a. Therefore f of z minus c is either a analytical at a or it has pole at a, but this is a contradiction. Suppose f of z minus c has essential singularity at z is equal to a given, so modulus of f of z is less than 1 upon epsilon lead to contradictions. Thus there should be at least one of the point for which modulus of gz is greater than 1 upon epsilon, that is modulus of 1 upon fz minus c modulus close is greater than 1 upon epsilon, or modulus of starts f of z minus c modulus close is less than epsilon.